The theme of this week in data science is the recent train derailment in East Palestine, Ohio, spilling lots of hazardous materials, killing lots of animals. The railroad responsible was Norfolk Southern. They do most of their work in the eastern part of the country. And they're one of the more popular railroad companies that exist. I think they're number 4 in the United States. So a lot of information in the news about this spill, who's responsible, and what we're going to do about it. And so I thought we would take a look at some of the data related to train accidents that have occurred over the last several years. In this section, we're going to be looking at ideas from chapters 13 through 15. We're going to look at strings and factors and the relational database functions that we used in the past. So for this assignment, we're going to be using, of course, tidyverse. So make sure you install that and all the packages. We will get to some string commands and some factor commands as well. We'll also be reading in several CSV files because that's the way they're given to us online. The first thing that we're going to do is we're going to read in several CSV files. I'd like to take you to the site where I grabbed these files. These are available to anyone who wants to have access to them. This is the Federal Railroad Administration site, and they report all of their safety statistics here by accident. And so you're going to find all kinds of detailed information about every single accident that has occurred in the United States on our railroads. You have to select the year, and you can select years all the way going back to 1975. And let's just say we're going to select back in 2015. We want to get all the reporting, all the states, and then you can select your format, Excel, CSV, or otherwise, and then you just click this generate a file. And what happens is down here, this is an active link. You click on it, and it'll upload your CSV file. There are several other data sets in here. All of these employee job codes, casualty codes, what are the causes of these train accidents, and they give you a code for each one. We're going to download that one. All of the different railroad companies in our main data file, all the accidents, it just has a railroad code. And this particular file links the full name of the railroad with the railroad code. And there's some state codes here as well. In our big data set, we have just numbers to represent the states, and we have to use the state codes there to link them. Part 225 reporting railroads is pretty much the same as the railroads, so we'll be using those as well. Now, I have downloaded all of these files, and so if you need to use them, then you can just copy the files that I have provided. So here are some of the different files that we're going to use that were downloaded from the train accident site. The code for the mechanical electrical train failures, I'm just going to call these the cause codes. And then there's also failure occurrence codes. This is another set of codes that I downloaded there. The state codes. We'll take a look at these in just a second, and then the different railroads. Now, one of the things that as you're importing these CSV files, for example, this one here, if we take a look at this guy, you'll see that it has several different rows up here of NAs and various other things. It looks like the titles begin here, and then the data begins here. So if row 6 is our column totals, then we want to get rid of 6 rows so that the 6th row there, which is what we want it to be, it's going to be our header up here. So we get rid of 6 different columns to make this one right. And that's what the skip 6 here means. If I skip 6 and then bring in the same file, you can see the header columns are what they should be, and so on. It does look like I have an additional column over here I don't want. And so I'm just going to go ahead and do this little piece of code right here, which says just select the 3 main ones, and that way we won't select that 4th logical column over there. And then if we run this again, you'll see now that that 4th column is missing. So do this with each one of your imported data files so that you know that it's in the tidy version format that we're interested in. All right, so you can view each one of these mechanical electrical failures, failures of occurrences, codes, and then the railroads, and here they are up here. You can see they're short. You give a code, and then it describes what that code is for this particular accident or failure. The railroads, you can see the code there, and then the railroad name also has a region. The mechanical electrical train failures, it gives a category for the accident, what caused the mechanical failure, an overall title, the description of the code, the brake codes. You have brakes, and you have various other sorts of category mechanical failures. All right, so the next thing we're going to do is we're going to bring in a lot of these accident reports. And so each one of these is an accident report for each year. And I'm going to just look at the accidents from the years 2011 to 2019. So not quite a decade. But here are the accidents. Each one of these is in the same format. These do not need to be tidied up at all because they're already in good shape. And then what we're going to do is we're going to combine all of these because the files are pretty much the same. There's a file for 2019 accidents and a file for 2018 and so on. What we're going to do is group them all together using the row bind command. And we're just going to create a new file called accidents, which merges all of these individual year accidents forms. So you have to type them all in here, and it combines all of the accidents together. Here's some useful code. When you do the dimensions of this, for those 9 years, turns out that there were 23,000 different accidents that occurred in the United States on the railway system. All right, so let's take a look at just a couple of things, a number of accidents by year. You can see what we do is we group by year, and then we summarize for each year, giving the count, and then we're going to arrange those in decreasing order by year. This would give us a subtotal for every one of the rows. To get rid of the duplicates, we'll do distinct. And when we do that, you can see here the year 2019, and you can see we have anywhere from 24, 23 to 27, 2,800 accidents every year. All right, and if we want to do a time series plot of that, then here's the code that would do that. Now, what I've done is I've pretty much grabbed the same code up here because I want to group by year, but then I want to put it together with a ggplot. And so the ggplot I'm going to create is the one where we have year along the horizontal scale, and then we're just going to count by years. And then when we run this, and here's the time series plot, total accidents by year. Notice we do have a funky looking scale down there at the bottom. I'll fix that later on, but anywhere from about 2,300 to 2,800 over time. And we could put a scale on that to make it look a little better. So let me go ahead and grab some extra code there to make this a little nicer of a curve. So we'll add this code here. If this is on the x-axis, we want to go from 11 to 19. Those are our years, and we're going to put a break at 11, 12 through 19. So we get rid of this 12.5 and 15.5 business. And then on the scale, the limits, let's go from 0 up to, let's say, 2,800, and then run this one, and we'll take a look at the graph again. So this would be the graph if it wasn't misleading. And we started it with 0 right down at the bottom. You can see it doesn't go up and down as it looked like it did. So right here is another picture, 23 to 2,800, and you can see the individual points by year now. So you want to look at the total accidents by railroad company. The variable inside our accidents frame is called railroad, all caps. So we're going to group by the individual railroads. And then we want to print these two columns, the railroad and the count, arrange them by decreasing count so we can see the largest ones first, and then get rid of the duplicates. And we get rid of all the duplicates. All right, so if we wanted to write the entire name of the railroad instead of just the abbreviation, we would have to bring in the information from the railroad's frame. And there you can see it, the railroad reporting code down here. Is this number here. This is also listed in our main accidents database, and this is known as the railroad. The 4 data frames, the 4 tables that we are connecting appear on this slide here. You have the main data frame, the main table with all of the train accidents from 2011 to 2019. You have these mechanical failure codes, and it turns out that this code up here is linked to the cause code in the train accidents. You have the state codes over here. It's just a number of a state code, and that's linked over to this number code in the train accidents. But the state codes also have the full name of the state as well as the 2-digit alphanumeric code that it uses. And finally, the third one is a listing of all the railroads, the region of the railroad reporting code, and that's linked up with the railroad code from the train accidents table, and then the full railroad name. So you'll be mutating to join a couple of these data tables, data frames together in order to print out some useful tables or some useful graphs. So we want to link railroad from our main accidents database to the railroad reporting code of the railroads frame. And we're going to do that by a mutating join. This time we're going to use an inner join, and then we're going to connect them together. So here you see it. It always prints this, it always prints the column that has joined. This is the full name of the railroad company, and this is the number of accidents that they've been involved in. And if you want to create a horizontal bar graph with railroad companies that have more than, say, 1,000 accidents, we can filter so that after we identify the count, we can filter all those out so that we only want those that have a count more than 1,000. We're going to do a ggplot by count and name. And when we do that, we see the spelled out names. Railroad company, got a couple of good labels. We've got a title up at the top, and we've got our 4 top rail companies. Notice here's 1,000, and they all have more than 1,000 accidents, and there are no other companies that have more than 1,000. So these are the big offenders, and they also have, of course, happen to be the biggest railroad companies. If we wanted to take a look at the number of accidents by individual states, again, we're going to group by state, count up the number in each state, get rid of the duplicates. So you've seen this over and over again. And there it is. And here's the state. We just don't know what these state number codes are. But we do see that the biggest offender has 2,848 accidents. So if we take a glimpse at X, you'll notice when we get to the state field, that the state field is listed as a number, as a double. When we look at take a glimpse of the state code, we'll see that the column that we have to link it to, numeric code, is a character. And so why don't we go ahead and just change the state variable in X to a character? Then we'll be able to join them with a mutating join. And notice now that state is now declared a character variable. So now both of the ones we're trying to link, and state codes the numeric code, and then in X the state, we're going to link them together. And if we want to shorten that table a little bit so we can see what we've just done, you can see we now have a listing of the states, not just by number, but by 2-digit state code. And we have a listing of all the counts of each one of those. Okay, this next one, we're going to link another 2 tables. One is the cause code, and the other one is with our accidents database. In the accidents database, we do have this column called cause, and we want to link it to what the full name of the cause is instead of just some cause code. So you can see under the cause codes there, you got this code number and a description, what category it is in, and then the larger title. So all brake in the category, all of these brake accidents are part of the mechanical and electrical. If you take a glimpse, you can see all of those fields are character fields. And when you look at our main accident database, you can see that these are all the causes, and some of them begin with E's, some of them begin with H's, some of them begin with T's, and it gives you the frequency of each particular cause code. And I think some of these have, up around 1,000. There are a couple with, 800 and some, and so on. All right, we're going to join together and then take a look. So you can see that since we're only looking at the cause, the description, the category, and the title, we're not going to see all of the fields from our our bigger data frame. If you want to take to look at what's in the category in X5 of all of the records that we have, here are the categories of the accidents. Brake has a category, locomotives has a category, and so on. By accident by category, the largest one is a locomotive, an error that occurred to the locomotive. That's usually the first, the engine. And there's 495 reported accidents there. And they go down from there. Brakes, number 5. I mentioned brakes specifically because that was one of the failures of the accident in East Palestine. So what we're going to do in this next graph is we're going to look at only those locomotives. And we're going to group them by year and see how the locomotive accidents have changed over time from 2011 to 2019. And when you look at that graph, you can see that the number of accidents started off in 2011 at about 30, and then it gradually went up to 80 after that, 2016, and then went down after that. So what could explain this? Well, I don't know. Maybe the locomotives are getting older. So over time, you're going to see more accidents related to locomotives. All right, so let's take a look at accidents one more time. You can see we've got the 23,146 different variables. This next blurb of all of the accidents to find out their location and plot them on a map. And these change the latitude and longitude numbers so we capture only the United States. So here it is. Here's a listing of all of the different accidents from 2011 to 2019 in the United States. You can see if I changed one of these numbers and went negative 176, what would happen is it would just create a lot of space that I don't need. And so I'm going to change this back to 126 so that I have the correct US map. In the next one, if we want to filter it so that we're only looking at locomotives, then this is what it would look like. There's not as many accidents that involve locomotives. Notice very few down in here. So not as many accidents that involve locomotives. Yeah, and so this next one, it's going to plot on the US map, but only those accidents that involved a passenger train. And here, I'm not filtering out by AM and PM, but what I am doing is I'm going to color one color for all of the accidents that occurred in the morning, and then it'll change a different color if the accident occurred in the afternoon or evening. So let's take a look. So not too many accidents of passenger trains, but you can see in here, this is where we have a lot of passenger trains in the United States, and there's not as many, some over here in Chicago and so on. Many of you may have taken trains from, say, Lansing to Chicago, but very few accidents that involve passenger trains. And those that do, most of them occur over here on the Amtrak train over there on the East Coast. And it looks like most of the time you have breakdowns in the afternoon and evening, probably because the trains are going, probably 12 hours in the afternoon, whereas in the morning they might only be going for like 8 hours. Another thing we can do is to plot the locations on a map where the CSX railroad was involved. So we can filter out by a particular railroad name. So let's filter out by that. You can see another thing I'm putting in here is a color. This one is, are there any cars damaged? So the big filter is going to be just filter out only those accidents that involve the CSX railroad. And then of all of those CSX railroad accidents, we're going to color them in case there was any damaged cars. So let's see how that looks. You'll notice I also changed some of these. I went from negative 100 instead of from a negative 130. And that's because CSX, they do not do any train routes over there in the west side of the state. So they're only over here. And you can see the blue ones are where we have damaged cars. And the red ones are not damaged cars in the particular accident that has occurred. Okay, we're going to switch it up a little bit now. You'll notice that our X has all these narratives, and they start talking here, and then if they have more to say, they go to narrative 2, and then 3, and then 4, and I think there's like 15 narratives here. So what we want to do, these are just all passages, texts. People are writing things, and we don't want to have to search 15 different columns in order to get the entire narrative. So what we're going to do is we're going to combine all those narratives together. And I'm going to do it in this way. Use the paste command. And we're going to paste all of these different narratives, individual narratives, and create a new one called just narrative instead of narrative 1, narrative 2. And we're going to separate each one with a dash. All right, now I'm not going to print out narrative because what it's going to give me, 29,000 paragraphs. But what we can do is we can specify the narrative in a specific record. And so this one here, this would be the narrative that corresponds to record number 1. Tread buildup on this produced enough wheel hop to cause the empty car to derail. All right, so, and then since there are 15 different narratives, you can see all these NAs mean that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of those narratives were empty. So it put NAs in there. Now, notice I did put the little dash between. So if I want to count the NAs, so I don't count things like Nancy or name, I'm going to look for dash NAs because all of these NAs have a dash in front of them. All right, the next one, if I want to read narrative number 27, this is what it says. And then you can be asked some questions about the string characters that appear. I notice this one, fire, appears quite a bit down in there. And then we're also going to count the NAs to find out how many narratives there were. All right, so let's take a look. This first one here, we're just going to do a string count. We're going to specify the particular paragraph, the narrative, and then what do we want to count? Fire. So we count fire, and if you look through that paragraph, you'll see the phrase fire, the character string fire, F-I-R-E, capitals, appeared 5 times. In the next one, what we're going to do is we didn't refer to a particular narrative, so it's going to look through the entire set of narratives and it's going to count up. It's going to give us a table of all the times fire was mentioned in the narratives. Of all of our different accidents, fire was mentioned once, 206 times. Fire was mentioned 6 times, 1 time. 5 instances of fire, that's what we had. We were one of the 4. And then finally, if we want to count the NAs, notice I put the little dash in front of NA and I get my 10. If I just say NA and try again, that also gives me 10. If I try space in front, then it gives me 0. If I do dash NA dash, if you were thinking that, then it only gives me 5. So it doesn't use one dash. Once it uses a dash, it gets rid of it and it doesn't count up anymore. Yeah, you want to play around with this to make sure it gives you what you want. I think the one that it wants here is NA. Now it gave me 10 with NA or dash NA. I think we want to use dash NA or space NA, something like that, because that'll avoid then counting up anything that has something like name or snap or something like that. Equipment damage, this is what is costly. And so maybe you want to do a search, see if in the narrative we have a phrase called equipment damage. So this is the command that does this assignment statement, and then we're going to do a table to find out how many times that actually appeared. Well, you only need to say it 1 time, I guess, but there was damage, costly damage, 97 of those accidents. And 1 time they mentioned it twice. Okay, let's create a factor. And I think this is useful if you want to rename, reclassify the categories or the labels, the values of a variable to include a, say, none of the above or a other category. And so to do that, we're going to use some of these factor commands. So the first one, we're just going to count the categories so you can refresh your memory. This head 10 just lists the top 10. That was our frame X5. And then here's the factor command that we're going to use, factor lump. What it does is it's going to create 6 non-other categories, and it's going to create the 7th other category, and it's going to sort them, and it's going to print as many categories as it can. In this case, it's only going to print 7. But let's take a look, and there you have it. It's got the 6 categories plus the 7th one right there is other. Now it puts other in the list instead of putting it at the end. And then if we take that same information and use that same mutate factor lump command and put it inside as part of a graph, and you can see the 7 different types here, other being at the top. Okay, when we look at IYR, that's year. It's just a 2-digit year. You can see I have the years 11 through 19, 2011 through 2019. And we have somewhere between, 250 and 300 accidents every year. And then the final thing we're going to do is draw a graph. We're going to use our 7 categories, and we're going to draw 1 time series plot for each one of those 7. We're going to count by year and by type. And we're going to group by year. We're going to create this new variable, which basically gives us a proportion. And we would have then the proportion of responses of a certain type. That's going to change. You can see down here, we're going to change the y-axis to be that proportion. And the x-axis is going to be the year. And we're going to reorder the factor. This is another factor command. Type first, then year, then proportion. And then we're going to draw the scatter plot, connect them together with a line. And then the legend is going to be the cause of the accident. So here are our 7 different time series plots. Again, you can see the year down here is not so fancy, but these are the proportions now. And you can see that the highest one was a coupler and draft system, somewhere between 15 and 20% of those. Locomotives, that seems to be the most popular way to break down here in 2011 through 2019. And axles and journal bearings, not so much. Brakes in the green curve here. So, and then you can investigate those trends, and you probably want to go back and make the graph pretty, add a title, and update these axes labels. Okay, so we've had some string commands and we've had some factor commands, and we went back to chapter 13 and we have some relational data, mutating joins. And you put it all together in a context that is relevant today: train crashes that involve hazardous material where the brakes fail in Ohio. And you can look at all the data to find out how usual, how unusual this is. And looking at data like this could inform public policymakers, lawmakers.